Okay, so this week let's do the feed rate optimization. So let me go and choose all. So fluting, you will do both air and grinding. Plunge heel clearance, we are doing grinding only. Radius gashing, we are doing both. And primary relief, let's only do the air only, because grinding I want to go at the program feed rate. Now we've got a minimum gap of 1 millimeter because you don't want to see the machine or the wheel approaching at a rapid feed rate or 1000 millimeters per minute very close to the tool, because it's a bit scary, but you can set it up to 0.5 or even 0.1 if you are confident your blank is square or you have done the right blank preparation. I'm actually setting up the Q prime values based on my previous experience to 3.5 in fluting and relevant, according to each of these operations and the wheel used, and the aggression factor I've set it, and I will explain this a bit more in the coming weeks. Put a maximum feed rate of 400 in the fluting, and I've set all this up, and when I hit apply, what it does is it does a calculation preparing the feed rate optimization, and that's what is happening now. And also it will try and look at the cycle time saved during this. So based on the calculation, the current tool is actually 7.5 minutes, whereas the optimized tool with feed rate optimization is only 5.5 minutes. You're saving around 2.05 minutes, and this is exactly what I said by saving cycle time using the feed rate optimization. Now in next week, I'll show you how this is applied actually in the feed rate mode and what can be changed, and how this all combined works, and what is the impact of this in the Sim 3D or the material removal rate.